Hello students, continuing Gmat series, the first question today is, if the smaller of two consecutive odd integers is a multiple of 5, which of the following could not be the sum of these two integers? Now see, he has given us that one of the consecutive odd integers is a multiple of 5 and that is the greater one. So we will look for the options. Now first is minus 8. Now in order to have the sum minus 8, see, for number system I told you that if we take positive in this direction, negative in this direction, now minus 1, minus 2, minus 3, minus 4, minus 5. Minus 5 is the smaller one. So larger one will be minus 3 and minus 3 and minus 5 is minus 8. Since there is no reference of sign, so we will be taking on the negative number line as well as on the positive number line. Now option B is 12. Now multiple of 5 means one number will be, let us suppose, 5n. The second number will be 5n plus 2. So addition, it will be 10n plus 2, provided if the value of n is 1. So the larger number on positive x-axis, which we refer in this case like this, but I prefer to take it like this so that on the negative number line you would be aware that those numbers which are on above side in comparison to the numbers which are on the downside, they are larger, right? So for this, the value of n, the number will be 5, but as the value of n becomes 2, it becomes the value 10, right? So in this case, it will be, this number will become 5 into 2, 10, and this is not a even number. This is a even number, not an odd number, right? Now, in order to have the sum 12, if the smaller odd number, which is a multiple of 5, is 5, then the larger one will be 7, and both are odd. So the total of 12 is achieved. So both these are okay. Now third, 22. 22 can be achieved if one number, in this condition if we follow, then n will be 2. So this will become 10 into 2 plus 2, 22. But first number has to be 5n. So 5 into 2 is 10 and the other number will be 12 and both are even. So 22 doesn't fulfill the criteria. Now for option D, since we have got the answer, but we will check for 52 and 252 also. Now for 52, the value of n will be 5, so 10.5 will be 2. So this is 52. For this 5n means n5 is equal to 5 into 5 equal to 25, and the next number will be 27. So and the next value will be 27 and the sum is 52. Now both of these are odd. So 52 is a sum of odd integers and they fulfill all the criteria. Now the last one is 252. Now for 252 we can have the value of n as 25. So this becomes 250 plus 2, 252. Now the first number, which is the smaller number, has to the multiple of 5. So this is 5n and 5 into 25 is 125. Now the second number will be 127. So this is 2, 12, 5 and 252. Now you see both the numbers are odd. So this also fulfills the criteria. So which of the following could not be the sum of these two integers? The right option is option number C, 20. Option number C. In the figure above, if triangles ABC, ACD and ADE are isosceles right triangles and the area of triangle ABC is 6. Area of triangle ABC is 6. Then the area of triangle, we have to find the area of triangle ADE. Now all these are isosceles right triangles. Right? This is the given condition that these are isosceles right triangles. Now moving on to the figure. So this is that figure. So here triangle ABC, its area is 6. So I will draw triangle ABC over here. So isosceles means that this side and AB and BC are equal. We can't say that AC is equal because AC is the hypotenuse and it is the longest side. So AB is equal to BC. Let us suppose this is equal to X. Right? Now, since this is a right triangle, so area is 6. So this area will be equal to 1 by 2 base, which is X, into X equal to 6. Or I can say X square is equal to 12. Right? So AB square is equal to 12, or I can say AB is equal to root of 12 is equal to BC. Now we know that AB is root 12, this is root 12. We can find out AC, which will be one equal side of the triangle ACD. So So AC square will be equal to AB square plus BC square. Now AB square is 12 and BC square is also 12. So this will be 24. So this implies AC will be equal to under root of 24. So this will be under root of 24. Now AC is under root of 24, then CD will also be equal to under root of 24. So AC equal to CD equal to under root of 24. From this we can get the side AD. So AD square will be equal to AC square plus CD square. So AC square is 24 plus 24. So this will be equal to 48. So this implies AD will be equal to 48 or under root of 48. So now AD is equal to DE. AD is equal to DE. I am drawing the triangle ADE. AD is equal to root of 48 and this will be also equal to root of 48. So we need to find the area of triangle ADE. So that will be 1 by 2 under root of 48 base into height into under root of 48. So under root of 48 into under root of 48 is 48 divided by 2. So this will be equal to 24 square units. So looking in the options, option B is the right option. Each of 27 white 1 centimeter cubes will have exactly one face painted red. If these 27 cubes are joined together to form one large cube as shown above, what is the greatest possible fraction of the surface area that could be red? So it says that if these 27 cubes are joined together to form one large cube and each of the 27 white 1 centimeter cube will have exactly one face painted red. So this is that cube, and he says that it is made up of 27 small 1 centimeter cubes. Right? The second thing is provides us a condition that one of the face of each cube is painted red. Each cube is painted red. Now, see, every cube will have its face shown, but there is one cube which is below this one, which will be having no face shown. So out of the 27 faces, 26, that is 27 minus 1, will be having its face shown. Right? Now, second thing is on each face of the cube, there are 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 9 faces. Right? So total 9 faces shown on one side of the cube, and there are total 1 in bottom and 4 this side, so 6 total faces, and for each cube there are 9 faces shown. So maximum possible 9 into 6 is 54 faces are shown from 27 small 1 centimeter cubes. But if we paint them, so we need to find the greatest possible fraction of the surface area that could be red. But the one cube which is below this center cube will have no face shown. So total will be 26 faces shown. Right? So only one of the faces is painted red. So the required ratio will be 26 by 54. So this will be 13 by 27. So right option will be option B. The figure above is constructed by separating a circular region into 6 equal parts and rearranging the parts as shown. If the diameter of the circle is D, what is the perimeter of the figure above? Now see, in this case he says that a circle of dia D, right, has been bifurcated into 6 equal parts. So it has been bifurcated into 6 equal parts, right? 1, 2, 3, 4, 5, 6. Now all these shapes have been joined together like this. 1, 2, 3, 4, 5, 6. Right? So the question asks us, what is the perimeter of the figure above? Now see, this is the arc, right? This is this portion, 1 and 2, 3, 4, 5 and 6. So it basically comprises of what? The circumference of the whole circle, right? Plus these two lengths which refer to this length, which will be equal to the radius, radius will be equal to d by 2, right? Now this part refers to circumference, which will be equal to 2 pi r, but in terms of d it will be equal to 2r is d, so this is pi d, right? Now these are two radii attached, so this will be one diameter or 2 times d by 2, so this will be d. So the total perimeter will be equal to pi d plus d. So the right option will be option D. If you want a more detail of this question, now see, we know that the length of the arc is equal to 2 pi r theta upon 360 degree. We are doing now analysis. Now, since it has been bifurcated into 6 equal parts, so at the center angle 360 degree divided by 6, it will be equal to 60. That means each of these will be having 60 degree angle. So that means this particular length of arc will be equal to 2 pi r 60 degree by 360 degree. So this will be 2 pi r by 6, or I can say pi d, because 2r is d and the options are in terms of d. So pi d by 6. Now there are total 6 such equal parts. So the total length of arc will be 6 multiplied by pi d by 6. So that will be equal to pi d, right? Plus these two radii at the outer periphery. We will not add these, as these don't add up to the perimeter of this figure. So total will be pi d plus d. Option D is the right answer. On a scale drawing of a triangular piece of land, the sides of the triangle have lengths 5, 12 and 30. Right? So the sides of the triangle are 5, 12 and 13 centimeters. If 1 centimeter on the drawing represents 3 meters, so the scale is 1 centimeter is equal to 3 meters. Now, what is the area in square meters of the piece of land? See, normally you would calculate the area of this triangle given the sides with the help of Heron's formula, right? But if you look closely, these form a Pythagorean triplet. These form a Pythagorean triplet. That means that sum of two squares of two sides is equal to the square of the third side. So that means this is a right triangle with sides 5, 12 and the longest side is always the hypotenuse. Now you can check it. 5 square plus 12 square, which is equal to 25, plus 144 is equal to 169, which is the square of 30. So whenever you look for such triangle, if you have to solve it by Heron's formula, it will be somewhat time taking. But if you know that this is a Pythagorean triplet, I would show you some of the Pythagorean triplets which are important. So you can take a screenshot and hang it wherever you study. So here you see 5, 12 and 13 are Pythagorean triplets. If you want how these are calculated, you must remember some of these important Pythagorean triplets. So the area for this will be 1 by 2 base into altitude. So that will be 1 by 2 multiplied by 5 multiplied by 12. So this will be 5 into 6, 30 centimeter square. See, here centimeter square is 2 times. So while scaling, you will do 30 multiplied by 3 multiplied by 3. Fine. So that will be multiplied by 3 multiplied by 3, so as to change into the scales. So this will be 3 3 is 9, 327, 270 square meters. Or if you don't want to do over here, you can simply convert 5 centimeter multiplied by 3 equal to 15 meters. 12 multiplied by 3 is equal to 36 meters. Right? Now you can calculate the area. 1 by 2, 15 multiplied by 36. So 2 cancelled and 2, 18 is 36. Now 18 into 15. I have told you how to calculate this. 18 into 15. 18 into 10 is 180. And this is 5, which is half of 10. So that will be 90. So this will be 270 square meters. Right? So in scaling, what we need to do, every unit has to be converted. So there was involvement of 2 centimeter units, so I multiplied it by 2 3s. Otherwise, simply if you do by singly multiplied by 3, so this will be 90, and you see here 90 is also an option. So this is not the approach. We have to multiply it by 2 times 3, or we simply change the scale before applying this formula. Which of the following gives all possible values of x in the figure above? Now see, figure is not drawn to scale. For this, we know that there is a theorem which says that the sum of any two sides of a triangle is always greater than the third side, and the difference of any two sides is always less than the third side. So sum is 4 plus 3 is 7, and the difference is 4 minus 3 1. So the length of the third side x will always be greater than 1 and less than 1. So the length of the x will always be greater than 1 and less than 7. So let's see. So here option B is the right option. If you want to make your concepts more clear, you can study 8th, 9th and 10th NCERT maths, and you can easily download it from NCERT website, and you have to read between the exercises. Between exercises, you must read there the concepts lies where they have been given lot of examples to make your concepts concrete. In the figure above, lines are drawn at the vertices of the quadrilateral as shown. What is the sum of the degree measures of the marked angles? So you see, at every quadrilateral, let me draw the figure first. At every quadrilateral, this angle, at this quadrilateral, at this angle, and at this angle. lines are drawn at the vertices. So these are those lines. Now if you look closely, these are straight lines, and the angle found on a straight line is having some 180 degree. So that means including this angle, the sum of at this all, let us suppose this is 1, 2 and 3 and 4. So the sum of all these three angles will be 180 degree. The sum of all these angles will be 180 degree. The sum of all these angles will be 180 degree, and sum of all these angles will be 180 degree. So that means 4 times 180 degree is the sum of the angles made at these straight lines formed at touching the vertex of the quadrilateral. But we need only the sum of these angles, not the green one. So we know that angle 1 plus angle 2 plus angle 3 plus angle 4 will be equal to 360, because sum of all the angles of a quadrilateral is equal to 360 degree. Right? So minus 360 degree will be the required answer. So this is 720 minus 360 is 360 degree. So the right option for this will be the option B. Now this was a quadrilateral, so you knew that the sum of the angles is 360. But if you have a quadrilateral or any n-sided figure, so the sum of interior angles for that, there is a formula, n minus 2 into 180 degree. Now for triangle, n is equal to 3, number of sides are 3, so n 3 minus 2 is 1, so sum of all the angles of a triangle is 180 degree. Now for quadrilateral n is 4, that n is number of sides, right? So n is 4, 4 minus 2 is 2, 2 into 2 is 2 into 180 is 360 degree. For pentagon, let us suppose if there is a figure pentagon, so n is equal to 5, so 5 minus 2 is 3, 3 into 180 is 540. So this is the formula for sum of internal angles of a n-sided figure. Right? Moving on to next question. The dimensions of a ream of a paper are 8 1/2 inches by 11 inches by 2.5 inches. The inside dimensions of a cartoon that will hold exactly 12 reams of paper could be. So the dimensions of a single ream of a paper is 8.5 multiplied by 11 multiplied by 2.5. So multiplied by 2. So these will be the dimensions of inside dimensions of a cartoon. Now options are 8.5 by 11 by 12 inches. That means 12 is wholly and solely multiplied by 2.5, and 25 by 10 into 12 will be equal to, so this will be 5, here it will be 6, this will be 5, so this will be 30. So here it is, in option it is 12 inch, but it should be 30 inch because 12 is wholly solely multiplied by, because 8.5 is as it is, 11 is as it is. So option A is not the right option. Now, moving on to the next option, 17 by 11 by 15. So that means for option B, 2 has been multiplied to 8.5, right? So 8.5 into 2 multiplied by 11 inches. So 11 is as it is. Now, out of 12, 2 has been multiplied to this. So left is 6. 6 must be multiplied by 2.5. So 6 into 2, 25 by 10. So that is 2, and here it is 5, and 5 to 10 and 3. So this will be 5, 15 inch. So this must be 15 inch, and in the option also it is 15 inch. So option B is the right option. We'll go for the next options also. Now this is 17. So again for this C option, 8.5 has been multiplied by 2. Now by 22, that means 11 is also multiplied by 2. So 2 into 2, 4 has been extracted from this. Now we are left with 3. So 2.5 multiplied by 3 will not be equal to 3. So option C is also discarded. Now, option D is 51 by 66 by 15. So this is far much than that. So 8.5 into 2 is 17, and 17 into 3 is 51. So that means 3 into 2, 6 has been multiplied to 8.5. Now we are left with only 2 out of this 12. So 66, 11 into 6. So this is not the option, as it is exceeding the multiple of 12. Now the last option E, which is much greater. 102 means 51 into 2. So here it will be 3 to 6 into 2, 12. Singly whole 12 is multiplied by 8.5 to get 102. So these two dimensions should remain the same, 11 into 2.5. So here it is 132 by 30, and all the dimensions are in inches. So right option is option number B. In the racetrack shown above, regions 1 and 3 are semicircular with radius r. If region 2 is rectangular and its length is twice its width, what is the perimeter in terms of r? So first of all, we'll draw the figure. So it is a region 2 is a rectangle, and a semicircle of radius r has been drawn at its end. So this is region 1, region 2 and region 3. I see is that the semicircular region is having radius r. So that means this will be r, this will be r, this will be R. So the total dia which forms the width of this rectangular region is also the dia. So that is width of region 2 will be equal to 2R, and we have been given that its length is twice its width. So its width will be equal to twice of this, so that will be 4R. So length of the second region will be 4R. Fine. Now to find the perimeter of the track in terms of R. So perimeter is this plus this and this side and this semicircular portion. Now, the perimeter, or we call circumference in case of circular regions, this is semicircle, and we know that circumference of a circle is 2 pi r. So these are two semicircles with same radius. So this will be 2 pi r whole, or this semicircle region will have circumference or perimeter equal to pi r. This will also have circumference equal to pi r. Pi r plus pi r will be 2 pi r. And for this region the length is 4r, so this will be also 4r. So this will be 4r plus 4r. Twice of 4r is 8r. So 2 pi r plus 8r. Now we'll take the common. Common in this will be 2r. Okay? So 2r, here it will be pi plus 4. So the right option is here 2r. See, there are 2r in first three options. Pi plus 2, pi plus 4. So option B is the right answer. The figure above is divided into 6 sectors of equal area. Contains an arrow representing a spinner. So if the spinner is rotated 3840 degrees in clockwise direction from the position shown, which of the following indicates the sector to which the arrow on the spinner will point? Now see, this region has been divided into 6 sectors of equal area. So each sector will have an angle 360 degree divided by 6, so that will be 60 degree. So the measure of each of these angles is 60 degree. Now it has been rotated 3840 degrees in clockwise direction. First of all, we will see the multiples of 360. So 360 degree multiplied by 10 will be equal to, 3600. So 3600, that means after 10 revolutions the spinner will come to this point now. Fine, as it is the starting point. So after 10 revolutions, how much angle is left? 3840 minus 36 degrees to 40 degree. Now, after this it has to be divided 60 degree for this, 60 degree for this, 120, then 180, then this is 240. So after spinning 3840, it will stop at this figure. So we will see it in the options. In the options, option B is where the spinner will stop after making 3840 degrees of angle in the clockwise direction. When a rectangular vat that is 3 feet deep is filled to 2 by 3 of its capacity, it contains 60 gallons of water. If 7.5 gallons of water occupies 1 cubic foot of space, what is the area in square feet of the base of the vat? Now see, this question is saying that there is a rectangular vat, right? Suppose it is like this, right? Now it says that is 3 feet deep. It is having a height of 3 feet. Is filled to 2 by 3 of its capacity. So originally when it is filled with 60 gallons of water, it is filled with 2 by 3 of its capacity, which is height 2 by 3, height 2 by 3 of its capacity. So let us suppose its capacity in cubic foot of space is x. Total capacity is x cubic feet. So this should be equal to 60, or x should be equal to 60 into 3 divided by 2. So this will be 30, or 90 gallons of water it can store to its full capacity. So this is basically the capacity. Now he says that if 7.5 gallons of water occupies 1 cubic foot of space. No, so that means by dividing 90 by 7.5, I will get the actual cubic feet volume. So this will be 10, and this will be 1, 15, and here it will be 18. Further it will be 9, 5, 5, 2. So that means, sorry, here 3 5s are, and this is 3, 6. So 6 into 2 is 12 cubic feet of space. Now in this area is, this volume is represented by the area of this rectangular vat multiplied by the height. So it is 3 feet in height. So let us suppose the area is A. A multiplied by 3 should be equal to 12. This implies A should be equal to 4. So the area of this rectangular vat will be 4 square units. The right option is option number A. The figure above represents an antenna tower with 2 guide wires that extend from point Q 40 feet above the ground to points P and R. If the 2 wires have equal length, approximately what is the total length in feet of the 2 wires? So we first draw this. So there is an antenna which is 40 feet in height, and here this is a perpendicular. This is point P and R. These are the 2 guide wires One is PQ and one is QR. Now this length is 60 feet. Now a triangle QPR, this length and this length are equal. If the two wires have equal length, so this becomes a isosceles triangle. So we can say that PQR is an isosceles triangle having two sides equal. If we have no side equal, that is called scalene triangle. If we have all the three sides equal, it is called equilateral triangle, and the measure of each angle is 60 degree in case of equilateral triangle. Now there is a theorem which says that the perpendicular drawn from the vertex containing two equal sides to the third side bisects the third side in case of an isosceles triangle. So if I say this point is S, then PS will be equal to 30 feet and this will be equal to 30 feet, because the vertex, the perpendicular drawn from the vertex containing two equal sides to the third side bisects the third side in case of isosceles triangle. Now triangle QSP now becomes a right triangle. Now we can find the side QP as by applying Pythagoras theorem. QP square is equal to QS square plus PS square, so that will be 40 square plus 30 square. Now this is again a Pythagorean triplet, so this will be 1600 plus 900, this will be 2500. So this is QP square, so QP will be equal to under root of 2500, which will be 50. So the length of this is 50 feet, and we need to find what is the total length in feet of the two wires. So the two wires will have the length 50 into 2 equal to 100 feet. Now looking for the options, option C is the right answer. The figure above shows a sealed container that is a right circular cylinder filled with liquid to 1/2 its capacity. If the container is placed on its base, the depth of the liquid in the container is 10 centimeters. And if the container is placed on its side, like in this figure, the depth of the liquid is 20 centimeters. How many cubic centimeters of liquid are in the container? So basically he is asking for the volume. So if we take a close look at this figure, I am drawing the front view of this. So it is filled to half of its capacity, and this has been given as 20 centimeter. So what does that represent? This represents the radius. So this is the radius, which is 20 centimeter. Now from the first figure, so it is like this, and in this case the height has been given as 10 centimeter. So this will become the height, or h, right? Because it has said that it is filled with its 1/2 of its capacity. So it is filled with 1/2 of its capacity over here, 1/2 of its capacity. So at the center, when it is half, so this will become the radius. Now the volume of the cylinder is given by the formula pi r square h. Now we will go to the options. Now here pi has been retained in the options, so we will not solve for pi. So this will be equal to pi, radius is 20, so 20 square multiplied by height is 10. So this will be pi dot 400 dot 10. So this will be equal to 4000 pi centimeter cube. So right option is option number A. We have to check for unit also. You see 10 centimeters and 20 centimeters, so there is no unit conversion involved. The figure above shows a drop leaf table with all 4 leaves down. The tabletop is a square, right? These leaves down, the tabletop is a square, and with all 4 leaves up, the tabletop is a circle. What is the radius in meter of the tabletop when all 4 leaves are up? So first we will draw the figure. So it says it's a square, and when all the leaves are up, it becomes a circle. So it is like this, right? Now it is given that this length is 1 meter, and you are asked what is the radius in meters of the tabletop when all 4 leaves are up, right? So the radius will be half of this, right? Now this is a square, so this will be 1 meter, this will be 1 meter. So we know that the diagonal of a square is equal to √2 of the length of the side of square. Here that length has been given to be 1 meter. How we calculate this? So let us suppose this is a triangle ABC. This will be 90, as each angle of a square is a 90 degree. Now AC square will be equal to AB square plus BC square. So this will be 1 plus 1 square plus 1 square. So this will be 2. So AC will be equal to √2. So this will be √2 into 1 equal to √2. We have been asked the radius. So radius will be half of this. So this will be √2 by 2. If √2 would have been in denominator, we would have rationalized it. We will now look for the option. So option B is the right option. Or if this doesn't appear to be the option, the other option would be, now we can simplify it, √2 upon √2 into √2. So in that case this will be 1 by √2. So this is equivalent to √2 by √2. So option B is the right option here. If the diameter of a circular skating ring is 60 meters, the area of the ring is approximately how many many square meters. So diameter of the circular ring is 60 meters. So radius will be 50 meters. So area will be pi into 30 square. So now he wants the approximation. So this will be 900 into pi. This will be 900 into 3.14. Now 900 into 3 is 2700, and the 0.14 refers that it will be having somewhat value greater than 2700. So closest to this is option D. We can approximate this to 2800 just because all these options are less than this, and 10,800 is far greater than this value. So we can approximate it. But had it been, the options would have been 2900, 2700, 2600. In that case, we had to multiply 900 into 14 by 100 also, which is 14 into 9. 14 into 10 is 140. So this would have been 1 to 130, 126. So we would add this to 1. So this would have been 2826. But since the options are much far, we can easily approximate to the value of D, 2800. So what is the greatest number of blocks 8 cm by 6 cm by 9 cm that will fit into a storage space that is 60 cm by 72 cm by 96 cm? So since there are no unit conversion involved, all dimensions are in centimeters. So we will simply write 60 into 72 into 96. Let us suppose there are n number of blocks, so that can be achieved by dividing it by the dimension of a single block, that is 8 into 6 into 9. Now 8 into 9 is 8 9 72, so 72 gets cancelled. Now 6, this will be 10, so n will be equal to 96 into 10, 960. So the right option will be the option D. Sometimes Gmat in between gives you very easy question, and you know that the format of the Gmat is it will start giving you easy questions, and as you rise up giving all the right answers, the level of the question will become harder. But as you give some question on this answer wrong, it will again fall to somewhat easy category, and this again this procedure is followed. Each light bulbs numbered 1 through 8 are arranged in circle as shown above. The bulbs are wired so that every third bulb counting in a clockwise direction flashes until all bulbs have flashed once. If the bulb number 1 flashes first, which numbered bulb will flash last? So the options are 2, 3, 4, 6, 7. So what he's trying to say in this question is that starting from 1, the bulbs have been wired in such a way that after the first bulb flashes, the bulb which is the next third in the clockwise direction will flash, and this sequence is followed until all the bulbs have been flashed. So he's asking for which number bulb flash last. So first he says that if the bulb number 1 flashes first, so number 1 bulb will flash first. Now he says the bulbs are so that counting in clockwise direction flashes until all bulbs have flashed once. So he says that every third bulb, so the third bulb will be 1, 2, 3. So the next bulb will flash, that is 4. Then 4, then 5, 6, 7. Then 7, after 7 it will be 8, 1 and 2. Until now all are different. Now after 2, 3, 4, 5. So 5, then 6, 7, 8. Fine. Now after 8, 1, 2, 3. So all are different now. 4, 5, 6. Right. Now 7, 8, 1. So 7, 8, 1. Again this number will come. So the last bulb to flash is the 6th bulb. So the right option will be option D. Thank you for today's lecture. I hope you are enjoying the videos. See, there are different ways to solve a question in Gmat. But our two things in Gmat is very important. One is less time taking strategy. And second thing is procedure. If your concepts are too much strong, that Gmat tries to see what Gmat does. It asks a question and the probable one options A, B, C, D. It has the most probable options. If you do a mistake, you would land up to a wrong option. So if your concepts are clear, you can solve it with less time and with procedure. For that, I have recommended you 8th, 9th, 10th maths books. You can easily download chapter wise or full book from NCERT website and try to read between exercises, which you usually skip during your 8th, 9th, 10th classes. Thank you for now. Bye bye. Take care.